so this is our continuation of 9.5 properties of logarithms. All right, so I was trying to race through this problem and wasn't doing a very good job explaining it, so we're going to start over. First thing I did was I rewrote it as 300 to the 1/3. I know that I'm trying to somehow have it say just log of 3. I'm going to rewrite this 300 then as log of 3 times 100 to the 1/3. Now, I want you to note that this 1/3 goes with both the 3 and the 100. So I'm going to rewrite this then as the log of 3 to the 1/3 plus the log of 100 to the 1/3. All right? Then I'm going to move that 1/3 to the front. And so then I have, I'm coming up here now, I have 1/3 times the log of 3. There's that log of 3 that I wanted, plus 1/3 times the log of 100. So I have 1/3 times that 0.477 plus 1/3. I know what the log of 100 is. Remember, this is base 10. 10 to what power is 100? 2. The answer to this is 2. So I have 0.477 over 3 plus 2 over 3. So I have 2.477 over 3. The whole point is that you're not supposed to use a calculator, so that's how you would go about writing that. So I had to think about all my different properties, and I knew I was trying to find a log of 3. So that's how I did that one. Okay? All right, so let's turn to a little bit more practice that we're going to do in our notes. It says to evaluate without a calculator. So equals x. So 64 to the x equals 4. So I'm going to write these as a power of 4. I know 64 is 4 to the 3rd. And this is just 4. Power, I'm so sorry. Power to a power you multiply. So 4 to the 3x equals 4. Since they have the same base, and remember this is just 4 to the 1st, I can say that 3x equals 1, so x equals 1/3. Alright, let's go to number 2. This is a 1/5, by the way. So, and this is a base 10. So 10 to the x equals 10,000 to the 1/5. I'm going to rewrite my 10,000. I need these to be in the same base. So I'm going to rewrite it as 10 to the x equals, this would be 10 to the 4th to the 1/5. All I did was rewrite 10,000 as 10 to the 4th. So power to a power you multiply. So that's 10 to the 4/5. They have the same base. So x equals 4/5. So that's for number 2. All right, let's go to number 3. Equals x. So we have 25 to the x equals 1/5. I don't like that 5 down there in the denominator. So I'm going to say 25 to the x equals 5 to the -1. I'm going to rewrite this 25 with a base of 5. 5 squared to the x equals 5 to the -1. Power to a power you multiply, so that becomes 5 to the 2x. I'm just going to erase those parentheses. So that's 5 to the 2x. They have the same base. So 2x equals -1. That means the exponents must be the same, so x equals -1/2. Alright, this next one, that's a 7/12, by the way. we have the natural log of e to the 17th times e to the 7/12. All right, I know multiplication means addition, so natural log of e to the 17th plus the natural log of e, I put natural log of e to the 17th. I did not mean to put the e as the base. The e is the base, but that's not what this problem was saying here. Plus natural log of e to the 7/12. I can now move each of these into the front, but you know what? I don't even need to, because this does have a base of e. E to what power is e to the 17th? 17. Remember, this has a base of e. E to what power is e to the 7/12? Well, 7/12. So all I'm doing is saying, what is 17 plus 7/12? I get 17 and 7/12. All right, let's go to this next one. This one's really hard to see. It's a negative 1/6, and this is a 49 to the 4/3. Got lots of things going on here. I am going to start off by taking this negative 1/6, and I'm going to, because it's right now it's expanded, I'm going to condense it and bring it here. So I have log to the base 7 of 49 to the negative 1/6. When I bring it here, I'm multiplying by 4/3, so I'm taking negative 1/6 times 4/3. So I get negative 4/18, which would reduce to negative 2/9. And I realize that, so I'm going to go ahead and I can say equals x. So I have 7 to the x equals 49 to the negative 2/9. So 7 to the x equals, this 49 is 7 squared to the negative 2/9. So I'm going to keep going, and I've got, let's go up here, 7 to the x equals 7 to the, when I multiply, power to a power, you multiply, I get to the negative 4/9. Notice, got a common base. So x equals negative 4/9. That's for number 5. Alright, let's go to number 6. I've got multiplication, I've got subtraction. Let's go ahead and I'm gonna, let's go ahead, let's bring that 3 over. So I've got log to the base 0.5 of 16 cubed divide, well, no, I want to say divided by, yeah, nope, minus log base 1/2 of 8 to the 6th. Okay, so I'm going to keep going here. Alright, the subtraction means division, so log, I'm going to rate this 0.5 as a 1/2, 16 to the 3rd over 8 to the 6th. Alright, and I'm going to keep going here. I think it would really help if I did everything in terms of 2's. Because let's see, this is going to equal x, right? Because now that I have it written as a logarithm, I could say 1/2 to the x equals 16 is 2 to the 4th to the 3rd over 8 is 2 cubed to the 6th. And 1/2 is really just 2 to the negative 1st. So 2 to the negative 1st equals 2 to the 12th, power to a power you multiply, over 2 to the 18th. So 2 to the negative 1st equals 2 to the negative 6th, because 12 minus 18. Right? Did I forget my x? I forgot my x. 2 to the negative 1st to the x. I apologize. So 2 to the negative x. I just dropped the x accidentally. I was going to say, wait, that doesn't make sense. Now that I have the same base, I have that negative x equals negative 6, so x equals 6. Wow, that was a lot. But this is a really great problem because it helps us to practice everything. Helps us to practice bringing that multiplier to be an exponent, that subtraction is division, to write everything as powers of 2, to remember our exponent rules, to remember our negative exponents, just so much good practice there. All right, for these next couple, let's look at number 7. It says that log base 7 of 6 is, you know what, I think these were ones we were going to skip this year. I'm going to pause the video a second. I got to double check. Yes, those were ones we needed to skip this year. All right, let's look at 10 through 12. Rewrite is a single logarithm. All right, so the addition means multiplication. So log base b of x divided by y times y divided by b. Those y's would cancel, and I get log base b of x divided by b. Right? Here I've got addition, so it's going to be multiplication. Log base b of b squared over 5 times 5b. 5's cancel, and I get log base b cubed. Well, that's just simply 3. B to what power is b to the third? Simply 3, and we're done. All right, let's go to number 12. Natural log of 4a divided by b. Let's look at number 14. If the log of a equals 2 times the log of b plus 4 minus 3 times the log of c, find an expression for a that does not involve logarithms, which means we got to do some simplifying here. So let's kind of start bringing things together. Might need a little bit more room than I've got right here. First thing I'm going to do is I'm going to bring that 2 to there. So I've got log of a equals, not equals, I'm sorry. Log of a equals, yes, log of b plus 4 squared. So I took that 2 and moved it here. I'm going to take this 3 and move it here, and the subtraction means division. So it'll be c cubed, like that. Okay. And now, because they both say log, we can say that a equals b plus 4 squared divided by c cubed, because they're both log base 10. So this answer a must equal this b plus 4 squared over c cubed. So there's my answer for a that does not involve logarithms. Let's do number 15, last one. On this page, log of 175 plus log of 4 minus 2 log of square root of 7. I'm going to move that 2 and it becomes an exponent. So I have log 175 times 4. Now when you square a square root, it just becomes whatever's under the radical. So that's just going to be divided by 7. So I end up with log of, let's see, what is 175 times 4? 0 to 20, 28, I get 700, which becomes the log of 100. Well, that's simply 2, because remember this is a base 10. 10 squared is 100, so we just simply get